Hey folks, so you should have already completed your minerals pre-lab, and this is just an introduction to your lab assignment for this week. These are the mineral samples that you'll be identifying, and they are all they each have their own individual folder, so you can look at them, look at little video clips of them and photos of them, and use that to answer the blank, fill out the blank charts. You can absolutely, and you should, use the flow charts for determining the name of the mineral, and you should use the blank charts to record, or the test really, to record the mineral properties, or the mineral properties and name. So then, oh, that's probably distracting to you, huh? Let's do that. Okay. So from there, you will basically, you can submit this file as many times as you want. So my recommendation to you would be to do a few minerals and then click submit, see which ones you got right, which ones you got wrong, and keep kind of moving along until you have all minerals identified. So the lighting is a little funny here, but I'm going to do my best. So minerals are the basis of all rocks, basically. They're naturally occurring inorganic solids with a definite chemical composition. So inorganic means that they're not made from anything that is alive. So like organisms that make their own shells, those shells are not considered minerals because they were made by something alive. They're solids as opposed to liquids or gases, and they have a definite chemical composition. So there's a few minerals that you'll have to know the chemical composition of. Don't worry about that until next week. But I lost my train of thought already. That's a good start. Let's see. So you will kind of be, because there we are. There's that thought. So because they have a definite chemical composition, they're pretty easily recognizable. You put the same elements together in the same way, and you get properties that are fairly similar. So that's exciting. And what we're going to do today is we're going to learn a little bit about those mineral properties to understand how you can go about starting your mineral identification. So I'm going to kind of go in the order that your textbook and your pre-lab goes in, and start by talking about some of those physical properties. So if I sent you to your local mall and I told you to go to the food court and find the girl with the brown hair and the green backpack, it's kind of hard because you don't know exactly, because those are pretty common characteristics. Girl with brown hair and green backpack. If I told you to go to the mall and find the girl with the pink hair who was wearing no shoes in the food court, hopefully that would be or more likely that would be a bigger challenge. So what you're going to do today is, first of all, learn what those characteristics, what these mineral characteristics are, and then secondly, you're going to learn how you can identify each one of these minerals has its own pink hair. So you're going to figure out what is pretty unique about each one of these minerals. So let's start by talking about what some of those characteristics are. The very first one, which you'll see the charts are divided into, is luster and color. So let's start with luster. Luster is the way that light reflects off of a mineral. So there are lots of different lusters in sort of advanced mineralogy. For lab, we're going to talk about two lusters. We're going to talk about metallic luster and non-metallic luster, which seems fairly straightforward, and for the most part it is. So metallic luster occurs when you have a mineral that looks like it is a metal. So let's see if this is a shiny mineral for sure, right? So, and this is in fact a metallic mineral. The other thing that is true about this mineral is that it is silver in color. This is sample number 3, and you notice there's a lot of fun things about sample number 3, but one of the things is that it's super shiny. And it's super shiny because it is metallic. So super shiny and silver make it metallic. If you have all metallic minerals, just kind of as a cheat sheet for your brain, have to be silver or gold in color. So let's look at this one. This mineral is very shiny, but it's not silver or gold. Therefore, and this is sample 28. So therefore, sample 28, even though it's shiny, non-metallic. So again, you want to think shiny, and silver or gold. So 28 is an example of a non-metallic mineral. Then there are, so this one, for example, is a little bit duller than sample 3, but nevertheless, and I'll have the light a bit better for when I shoot the videos for these. Nevertheless, is silver. Let's see if I can do it this way. So this one is silver. This is sample 9. Yes. So sample 9 is also silver in color and shiny, therefore metallic. This guy here, this is number 27. You can see that he is shiny, but black in color. Therefore, he's non-metallic because he, I don't know why I made him a he. I shouldn't assume the gender of sample 27, but sample 27 is non-metallic because it is black. Okay. So the next property that you want to talk about is color. Color can vary tremendously in samples. So remember this sample, number 28, that I picked up earlier, the non-metallic sample. This sample of 28 is clear. But because of really minor impurities in minerals, they can be a ton of different colors. And so number 28 is quartz. It's quartz crystal. But you can have quartz that is pink in color. You can have quartz that is purple in color, and we call that amethyst. You can have quartz that is orange in color, and that's called citrine. Quartz can be almost any color of the rainbow, and for that reason, color is not the best identifiable property of minerals. It's easier to determine if a mineral is light or dark. One of the things that you'll notice on your chart, on your identification chart, is that if it's questionable that whether or not a mineral is light or dark, for example, number 11. Actually, no. Number 11 is definitely dark. Forget about that. But, oh, I know. Number 18. Number 18, some of our samples of 18, like this one, tends to be a little bit darker, but some of them are a little bit lighter. So sample 18 will appear both on the dark and the light chart, just to make it easier for folks. So you want to do color being light or dark and luster being metallic or non-metallic. And what you'll see when you go back to the web page is that there are going to be 3 charts for identification: metallic, non-metallic, and non-metallic light and non-metallic dark. So you'll use the appropriate chart based on the mineral sample that you're working on. So for example, number 28 again is non-metallic and light colored, so you would use the non-metallic light chart for its identification. Okay. So that is luster and color. The third property down is called a mineral's streak. And so streak is the color that a mineral makes when it's scratched on an unglazed porcelain plate. So what you'll see in each of the samples when you go through and identify is that I've made little videos of each one of the samples being scratched. So some samples will leave like nothing basically on the scratch plate. So this is number 30, I think. Number 30 doesn't leave not a thing on the streak plate. So for the streak for number 30, on my answer sheet, I would write down none or white streak. Not all minerals will be like that. So some minerals like number 2. So here's number 2. You probably can tell that number 2 is also a metallic mineral. If I take number 2 and I color on it, number 2 leaves behind a black streak. So some minerals will leave streaks that you might expect, and others won't. So number 9, which I brought over here, number 9 is this metallic mineral, and number 9 is silver. But when you take, here, let me clean off my streak plate a little there. When you take number 9 and you scratch it on a streak plate, let me move that closer, you can see. Number 9 streak is like a reddish brown streak, even though the mineral itself is silver. So streak is really useful for identifying certain minerals and not for others. But regardless, it's one of those really distinctive properties for certain minerals. All right, so let's put that aside. And the next one we're going to talk about is a mineral's hardness. So minerals basically are measured as which one is harder and or can scratch the next one. And Mohs hardness scale is used generally to determine a mineral's hardness, and most of the minerals, if you look in your textbook, most of the minerals that you have in Mohs hardness scale, you actually have in lab. Not all of them. I believe, well, obviously you don't have diamond in your kit, and I think almost every other one you have though. So let's see if I can do this closer. I'm just experimenting here. Let's see. Oh, that might be better. Sorry, we're all learning together. Okay. Oh, and then I can play with the resolution. Okay. So, ooh, I'm not sure if I like this yet. We'll see. So, hardness. So Mohs hardness scale goes from 1 to 10. And the softest one is 1, and that's talc. And the hardest one is 10, and that's diamond. You have a 9 in your kit, but you don't have a 10. So what we do when we're determining in the field whether or not, when we're trying to identify minerals in the field, we will use known substance, the hardness of known substances, like your fingernail. Your fingernail has a hardness of about 2.5, and there's certain minerals like sample, oh, I don't want to use that one, 17. So here's sample 17. You might notice sample 17 is really flat right here. You might notice, ooh, I could use some moisturizer. Sample 17, you might notice that it has these really thin layers. And sample 17, if I take with my fingernail, I scratch it, it creates a powder. And the fact that it creates a powder means that my fingernail is harder than the sample, or the sample has a hardness of less than my fingernail, which is 2.5. So sample 17 has a hardness of less than 2.5. So that's exciting. Other minerals, most minerals, in fact, I can't scratch with my fingernail. So here is sample 14, and nothing is happening there. And the next thing I can do is take the next hardest substance that I might happen to have with me, which in this case is a glass plate. Glass plates have a hardness of about 5.5 on Mohs hardness scale. And sample 14, if I take the same one I just had, is softer than glass. So if I take it, like you hear, I'm going to move the microphone closer. Hopefully you heard almost nothing. You just heard me rubbing the sample on the glass, and that's because it didn't scratch the glass. So I would say that sample 14 has a hardness, it's harder than my fingernail, but softer than glass. So I would say its hardness is 2.5 to 5.5. And then if I take a mineral that is much harder than glass, or reasonably harder than glass, like number 28 again, if I take number 28 and I scratch that, not only will it leave a scratch on my glass plate that you'll be able to see, but you can also hear it. So if you have a microphone, or if you have, hopefully you have your sound on because I'm talking to you, but please turn it up so you can hear this. This is pretty cool. Did you hear that? It sounded a little bit like nails on a chalkboard, right? So then if you take your glass plate and then kind of move it here, let's see if I can get that to focus a little bit better. It's hard because it's glass. What you basically can see are some lines back and forth that I just made in this glass plate. So anything that can scratch a glass plate has a hardness of greater than 5.5. So hardness, again, super useful for some minerals, not so useful for other minerals. All right, so let's see. I'm going to save that one till the end. Some minerals have really unique properties, and those are probably the fun ones. If you have this particular mineral, this is sample 15, you probably see that sample 15 is a cute little rhombus or a rhombohedron. Sample 15 does something really fun when you put, this is 10% hydrochloric acid. It is not remotely dangerous unless I drink it or put it in a cup, which I'm not going to do. But when I take hydrochloric acid and I put it on certain samples, like sample 15, fun things happen. So this mineral will react vigorously to hydrochloric acid, and then I'm going to dry my sample off because I don't want the acid to eat its way through the sample. Sample 15 is the only one that really is going to react right away. I do have another sample that is less fun to watch, but sample 16, which also, incidentally, is a cute little rhombus, sample 16 does something different because, okay, so sample 16, if I put my acid on the top, like nothing happens, which is very unsatisfying. So let's dry that off. Sample 16 does something different though. I can take my glass plate and I can use my glass plate and scratch the top of sample 16. 16 is the only one that does this. So basically I've just created a powder of sample 16. I'm sorry for getting seasick. Okay, so there's my powder that I've made with my glass plate, and now I'm just going to take some acid and put it on the powder, and you'll see a couple of bubbles right underneath the acid. Do you see that, like right in there? It's not really exciting. It's a weak reaction, and it only happens after you powder it, but nevertheless, sample 16, that's what it does. Pretty good. Okay. Other miscellaneous minerals, or miscellaneous properties, would include sample 10. So, I have to figure out a better way to do this. Oh, I lied, because that's sample 5. Where's 10? There is sample 10. Sample 10 is a metallic mineral, and it's kind of lumpy. But sample 10, if you have a magnet, the magnet will stick to sample 10. It is strongly magnetic. So that's kind of handy. And conveniently, it's called magnetite. Hard to beat that in terms of fun ways to remember things. Let's see, here is sample, maybe, 12. So sample 12, you might notice, is a perfect little cube, or sort of a rectangular prism, and it is clear. And guess what? You can't tell this virtually, and there's no way I can communicate this to you other than to tell you it is. Sample 12 totally tastes salty, and one of my favorite things to do in my face-to-face class is watch my students lick this sample. Oh, and my dog's going crazy, so we're going to pause it here. And if you even look at like the side here, you can see that when it breaks, it's going to break again into another little rectangular prism. This is considered, so a lot of times, 3 directions of cleavage that meet at 90 degrees, like 1, 2, 3. That's called cubic cleavage. And again, here, let me grab a pencil here. Like there's a 90-degree angle right here. And then another one here. That's a 90-degree angle. And then another one here. So, good stuff. So this is 3 directions of cleavage that meet at 90 degrees for number 12. So, where did my little sample 15 go? Okay. So sample 15 also has 3 directions of cleavage, but they don't meet at 90 degrees. This is that rhombus that we looked at earlier. So there's one set of flat parallel sides here. There's one at the top and the bottom there. And then you have flat parallel sides on the sides. That's direction number 2. And then the front and back, that is direction number 3. And you can see that as you turn it around, it's a rhombus on all sides, which is super fun. A perfect little rhombus. So this has 3 directions of cleavage that meet at 60 degrees, and this is called rhombohedral cleavage because all sides of this mineral are little rhombuses. Okay, so the last one I'm going to show you is this particular mineral. This is sample 14, and tell you that there's an exception to the rule coming up in just a minute. So sample 14 is a soft mineral, but what you always see in this mineral is a point. It almost looks like a little pyramid face, and then you see like triangular faces on either side, on all sides of the pyramid. So there's a second side, there is a much smaller third side, and so it was 1, 2, 3. So this is the fourth side of cleavage. And again, here's the top of the pyramid. So if we look at from the top of the pyramid, we can see 1, 2, 3, 4 directions of cleavage. So that's because when we smash this mineral with a hammer, it always breaks so that it has this pyramid peak at the top. So this is considered 4 directions of cleavage. You don't have to worry so much about what angle they meet at, because they all meet at this point here. Let's see. So that's fun. There are a couple minerals I do want to talk a little bit more about in terms of their cleavage. This is sample 4. Sample 4 is a common mineral that has a tremendous amount of cleavage. You can see that this looks like a little geometric shape as I turn it around, right? And sample 4, if we looked at its crystal structure, we would be able to identify that there's actually 6 directions of cleavage on there. Now, you cannot identify the 6 directions of cleavage. I cannot identify the 6 directions of cleavage. This particular mineral you can only identify all the cleavage planes if you had it under a microscope, and you could see more of the crystal structure. So you are just going to have to, this is an example that you are just going to have to memorize and take my word for it that there are 6 directions of cleavage, and number 4, put it in your chart. It actually is wildly useful when identifying this mineral. Let's see. Other challenges include number 22. So normally when you're looking for cleavage, you want to look for sets of flat parallel sides, and number 22 unfortunately totally violates that rule, because that is how the world works. So in number 22 is like black and green and kind of blocky looking. There's always 2 flat sides that will meet at nearly about 90 degrees. So that's like right there, and you can see that there's a nice flat side there, and similarly, oh, there it is, another really flat side there. So this number 22 is considered to have 2 directions of cleavage that meet at 90. Let's see, and there it is again, 1, 2. Next exception to the rule is number 23, and number 23 is right here. So number 23 is fun. This is actually a really complicated sample of 23, but nevertheless, number 23 is characterized by these really long, narrow crystals. What's fun is you can actually see that there's another mineral that kind of is growing through number 23. But nevertheless, you have these elongated blades or crystals. When you'll see this mineral in rocks, it always has those same sort of long, narrow crystals. It'll break into those blades. And what you'll also always see in 23 is that these long, narrow crystals climb up to a point or a horn, and then you can see more on the other side, and they meet here always at like a, well, let's see, here's a good example of where you have these long, narrow crystals that meet up here at a 60-degree angle. And I turn it to the side so you can see that these long, narrow crystals are climbing up this way, and they're climbing up this way, and they're meeting at the 60-degree angle, and it's right there. And this mineral actually, so it comes to a horn, and it's called hornblende, so all of you should get number 23 right. But it is also an exception to the rule, so this is 2 directions of cleavage that meet at 60 degrees. So I think that's enough for now. So get started, and when you have questions, ask them, but certainly do the best you can, and then submit the assignment. You'll see which ones you got wrong, and you are then encouraged to keep going and try and figure out what went wrong and how you can get to the right answer. And always, always, always feel like you can ask me for help, because I'm here. All right, thanks guys.